In this section, we're going to look at some of the properties of the representative elements. Starting with group 1A, lithium, sodium, potassium, rubidium, and cesium, we see that reactivity increases as you go down the group. Hydrogen forms a +1 ion and can be put at the top of this group, but it also could be put on the top of 7A since it forms a -1 ion, the hydride. The alkali metals are soft. They're very reactive. They react explosively with water, and they all form +1 ions. The group 2A elements are beryllium, magnesium, calcium, strontium, and barium. They too increase in reactivity as you go down the group. Alkaline earth metals are harder than alkali metals. They're somewhat less reactive, and they form +2 ions. Group 3A elements, boron, aluminum, gallium, indium, and thallium. Boron is found in the mineral borax. It's also used to manufacture boric oxide. Aluminum is a structural metal. It's lightweight, and it forms a very stable oxide, so it doesn't rust. Gallium is used in the semiconductor industry. Indium used in LCD and touchscreens like your phones. And tantalum is used in electronics. Unfortunately, it's very toxic. Notice that gallium melts at room temperature. Group 4A elements, carbon, silicon, germanium, tin, and lead. Notice here that as you go down the group, the metallic character increases. Carbon forms more than 10 million compounds. Silicon, very important in silicon dioxide, making chips. Germanium, used in the semiconductor industry. Tin is a metal, and lead is a metal. Group 5A elements, nitrogen, phosphorus, arsenic, antimony, and bismuth. Nitrogen used in manufacture of ammonia and nitric acid. Phosphorus has 2 allotropes, red and white, used in matches, toothpaste, and detergents. Arsenic is toxic. It's a pesticide and an insecticide, used commonly in rat poison. Antimony, used by the electronics industry, also to make paint and ceramics. And bismuth is diamagnetic. It's a brittle metal, and it's used in medicine and cosmetics. Group 6A, oxygen, third most abundant element, sulfur, used to manufacture sulfuric acid, gunpowder, matches, and insecticides. Selenium, xerography, what we typically call Xeroxing. The metal plate is made out of selenium. Tellurium is a metalloid, very rare, but used in the semiconductor industry. And polonium is a radioactive metal, not used for much. The 7A elements, the halogens. Fluorine is the most reactive. It's used in the manufacture of Teflon and sodium fluoride, typical additive of toothpaste. Chlorine is a gas. It's a pale green gas. Fluorine is also a gas. It's pale yellow. Bromine is a brown liquid. Iodine is a purple solid. And astatine is a radioactive solid. In this case, reactivity increases as you go up the group. The group 8A elements are the noble gases, helium, neon, argon, krypton, xenon, and radon. Helium is a lifting gas, also used by divers in breathing mixtures. Neon, used for signs and light bulbs. Argon, used in welding and also manufacture of light bulbs. Krypton in light bulbs. And xenon is the most reactive of the noble gases. Here are 2 pictures showing that some of these compounds of the noble gases are indeed manufactured. A number of xenon compounds are known, like xenon tetrafluoride, xenon trioxide, etc. and a few krypton compounds are known. Sir William Ramsay was the discoverer of the noble gases. Here you see discharge tubes showing all of the noble gases.